Alright, so hello and welcome. Here we are. Another problem to work on today. I am feeling really down lately. I don't know, the past few days have just been really sad. Thinking about a few different things. It's been kind of rough. It's been kind of rough. But solving problems online always kind of helps assuage my my feelings, I guess. So let's grab a problem. So we have implement magic dictionary, and we're going to use C++. So we're going to try to do this within an hour. Ooh, no. Try to do this within an hour, see how far we get. Design a data structure that is initialized with a list of different words. Provided a string, you should determine if you can change exactly one character in the string to match any word in the data structure. Implement the magic dictionary class. Magic dictionary initializes the object. Build dictionary sets the data structure with an array of distinct strings. Dictionary search returns true if you can change exactly one character in search word to match any string in the data structure. Otherwise, return false. Okay, so I think I understand. I actually don't have an immediate solution. This one is kind of involved. So oops. I think you use a string library too. Yeah, man. I think I've been saying this the past few videos, but just pain. Just I live with a lot of pain. It's hard to get my mind off it. Okay, so magic dictionary initializes the object. Build dictionary, string dictionary, sets the data structure with an array of distinct strings. Search returns true if you can change. You want to change exactly one character in search word to match any string in the data structure, otherwise return false. Okay, so I want to do this efficiently, right? So one approach is your naive approach is you could take the string and what do they mean by change one character? They mean add a character, literally change the character itself. I think they mean change a character, yeah. In other words, don't remove a character, don't add a character, but take one character and change it to another character. So LeetCoded doesn't match LeetCode, even though you would delete a character. There's too many. Okay, so actually, this might be on the easier side. Really, what you're looking for is first one check is that the character has to have the same length, the same number of characters. That check you can do very efficiently. You can have just a hash set of all of the unordered set, hash set of all of the, lengths. And then if you don't match any of those lengths, then immediately return false. So that's pretty efficient. But let's say you do match the length, right? So if you do match the length, you need to change at least just one character needs to be changed. So actually, what the comparison would be from one string to another would be that you can make a frequency map, and the frequency map needs to match except for one spot, and that one spot needs to be a difference of exactly one. Or no, excuse me, 2 spots. It would be, I think it would have to be 2 spots because you move because you change a character, you decrement on one spot and increment on another. So the hash map would need to be, and it has to be exactly one character. So actually, if you did hello, it's false, right? So the hash set, the frequency maps that you build of counting the characters for each string, the frequency maps would have to be different by exactly 2 character positions, and it would need to be +1 and -1 difference exactly, and then that would be a match, right? That you would change exactly one character. Now, what's tricky about this is you could do a few different things here. What's interesting is you can actually take each string in the dictionary and you can create 26 copies of each string and put those into a hash set as well, and then just check if this word no, I'm sorry. Actually, that's not correct either. No, it's not the frequency map. That won't work. That's not correct. I'm sorry, I take that back. No, that's wrong. That's wrong. No, no. All that's not correct. How about this? How about we want to, how are we doing on time? I don't have a solution, immediate solution, but at the beginning, I have at least an initial. So I mean, if you can make sure that the string is the same length, that's good. But yeah, we could just suppose a case where all the strings we're dealing with have the same length to begin with, right? And then now we're sort of back to the same problem. So that's not really good enough. What about? I mean, you can use like a. I want to say you can use a try data structure with your dictionary. But the problem with that is I'm not sure if that's quite right. Well, you're trying to match this word against all the other words in the dictionary. I mean, a really bad way of doing this would be to take all of the words in the dictionary and copy all of them with one letter changed. Which one is going to, so you're mapping, you're mapping exactly one character to match any word in the data structure. Okay. I want to say maybe you can use regular expressions here somehow. And I don't know if that makes sense though. Also, there's a slight difference here too, where the word you're searching for, the same word won't work. In other words, exactly the word in the dictionary is not going to work, but it's got to be exactly one character is different. So you got to be careful if you're going to try to use regular expressions. You have to make sure you capture everything except for the word. That one character staying the same. And only one character changes, huh? That's very interesting. Well, I mean, a naive approach is just take your word and loop through every word in the dictionary, your target word, we'll call it search word, or S. Check it against every word in the dictionary naively. And how big is the dictionary? Let's check that. Maybe we can get away with something inefficient. Dictionary length is only 100 words, and only English lowercase characters. All strings are distinct. Search word is 100 characters. All right, so we got 100 words, 100 length, and how many calls are we going to do? 100 calls to search. Okay. Once, 100 calls to search. All right, that's not bad at all. So we can actually make this pretty inefficient, and it'll still work reasonably well. I'm trying to think if there's a way to do this that's more efficient. Let's see. Yeah, we're already 9 minutes in. Sure. Yeah, we can do. Oops. If we want to make things more efficient, I don't know how we do it more efficiently, but inefficient, simple approach is check your search word against every dictionary word. So if that's 100 by 100, right, that'd be at least 10,000, and then each time you do that, you want to check, one character difference. I mean, that's a pretty easy check. You can do that manually. You just say, you can do. I'm trying to think if there's a way to do this using iteration that's like kind of efficient, like using the STL for this. Basically, you can add, for each character that matches, you can increment some count by 1, and then you can check at the end to see if that count doesn't match the total string length. That's one approach. I mean, actually, what you would have, probably a better way to do it is really just a Boolean. Like, you could terminate it early. You could say, you just check character by character. If they match, then continue. If they don't match, then set a Boolean to true. And then keep going. And then if that Boolean is already true and you find another thing that doesn't, 2 characters that don't match, then break early and set that Boolean to false and break early. So the Boolean return is false. If you make it all the way through, you'll return false, and then if you see a mismatch, it flips to true, toggles to true. If you see another mismatch, it toggles to false, and actually break early as well, and return that Boolean. So that's like a custom raw loop. I don't know how you can make I don't know exactly if you can use the STL for that raw loop. I think it's better to use a raw loop for that. Some things are a little bit more complicated, and I think raw loops are better. Yeah, that's simple enough. I mean, like I said, you could just run a routine where you just go through all of it, and each pass is 100 characters, and that's on 100 strings, and that's 100 times, which is not too bad computationally. Looking at 1 million, yeah, which is usually pretty relatively fast. We can do that. That's fine. It's just the thing about that is that there's got to be a faster way. Let's see how we do, I guess, if we can code this up quickly. I'm curious if this will pass the test cases as it is. I don't really have a better solution than that at the moment, but I think it'll be fast enough. So we're going to use just a vector of strings. Dictionary, and then sure. What we want to do is actually, it's like a fill routine. How do we, I guess it would be a copy. There's a couple ways you can do this, but let's look at the STL. I want to use one of the algorithms to do this. Oh, that's interesting. Maybe we'll use a mismatch routine. Let's not do that. Okay, copy. That's what we want. Yeah. Okay. Input, output, input first, out last. The range. Behavior is undefined. Now the question is, are these deep copies? I think you do get deep copies. I think so. And it's just standard copy, right? And we're going to say there's input, first, last, and then output. So input, first, last is dictionary. Begin. Now, I'm wondering, do we need to copy this in this way, or can we just set dictionary to this dictionary? That's a good question. I don't know if the copy assignment operator will actually do. Yeah, let's try that. Let's see what happens if we do this. I don't know. I don't actually know if we need to even run this routine. All right. So for string s in dictionary, we're going to write a routine. It's going to be, we're going to write this subroutine here. So auto check word, or check find single mismatch, or check single mismatch. Mismatch. And it's going to click the following. So going to say, how are we doing, by the way, on time? 16.5. Okay. All right. Terminate early. If string dot size in C++ is not equal to search word. Also, I think you have to be careful. Lambdas, you only capture what you need. Somebody explained that a while back to me, or I read that, saw that somewhere. If word sizes don't match. Yeah, I saw that somewhere online to do that. That's generally good to only capture what you need. So the idea is find exactly one mismatched character. If there are none, return false. If there are more than one, return true, or return false as well. Return true. Only if and only if exactly one mismatched character. Okay, so we have boolean or bool, and it's false. Do we not have bools in? Oh, we do. Okay, it just doesn't. It's not being highlighted for some reason. I thought. Oh, okay, it's fine. So we'll say false. And we're going to say int I equals 0. I is less than s dot size plus I. Character A is going to be search word of I. B is going to be s of I. If A is not equal to B, red equals true. We'll say if red equals true, then red equals false. Break. Else equals true. Toggle the return value. Toggled from true. A value of true. And then we know that we have found more than one mismatch. Okay, let's see, right, and then we want to say search on search word, We have the subroutine check single mismatch. And we're going to call our check single mismatch on S. And we'll say if we match any of these words, return true, otherwise return false. Something like this. See, that compiles. Start with that. Oh, it doesn't work. Oh, of course. Wait, what? I'm a little confused. There's a constructor and a build dictionary function. Oh, but this is only going to be called once. Right? Excuse me. This really should be in the constructor. That was why I was so confused. Why I was confused. And forgive me, I've been writing a little bit of JavaScript lately. JavaScript, you don't need the. Okay. There's another one here that I'm missing. Thank you. Yeah, this is more like an inline function for C++. Alright, so it works. Oh yeah, okay. I wasn't sure about this. I wasn't sure we needed a copy, so it's good to know. But yeah, the copy constructor works fine. Nice, that's good. Yeah, assignment. The copy assignment operator. Yeah, the copy assignment operator. Yeah, because there's also a move assignment operator, which is, yeah, okay. Let's go for it, see how we do. Moment of truth. Hey, oh, okay, done. That's it, that was it. Super simple, okay. That's 97%, it's probably about as good as you can do. Yeah, alright, fair enough. Okay. So yeah, these problems, sometimes they don't take that much time. I think the hardest part for me here was like thinking about how I could also, yeah, I think that's it as far as time, right? That's it, we're good. Just a couple things to note here. Like, I don't actually know offhand. We didn't think very hard about like what optimizations we could possibly make. I think you need to use a special data structure of some kind if you want to make this faster. This is kind of like naive, about as naive as it gets. But the bounds that they gave us were relatively small, so it's fast enough, it works. But yeah, interesting. I don't really know what to say here other than there's probably a more efficient way to do this that I just don't know about. We'll just say that. And so yeah, thank you for watching. Talk to you soon. I don't know if I'll do another one. I think I want to just hang out a bit. I've got an interview soon. But yeah, I wanted to just code something because I haven't in a while. What else do I want to say? If I knew that this was only going to be, this was as efficient as it was going to be, this probably would take like 5 minutes. But obviously it took me, we're at like approaching 25 minutes because I wasn't really sure. But yeah, thanks again. Talk to you soon. Have a good rest of your day, and that's it.